everyone, we are Team Artificial Stability, which includes Hao Mingchen, Lin Kunma, Xiangli Yang, Xuan Li, Yang Songzhang, and Weian Liu. Today we'll present our automated security testing bots. And let's begin. In this project, our task was to design and build a working prototype of an automated infiltration and data exfiltration bot in an approved and controlled lab environment. So this is meant we had to carefully plan every step from how the bot gets into a system and to how it extracts data and how it cleans up afterwards. So our goal was not only to make it functional, but also show clear reasoning, disciplined operations, awareness of threat simulation, and careful defense detection mechanism. So the infiltration and data exfiltration bot for Athea Digital is a modular system designed to run authorized attack simulation in controlled lab setting. It automates the whole process from finding the target to extracting data and cleaning up afterwards, so that defenders can measure and improve their detection and response. In simple terms, our bot can act like a real attacker, but in a completely safe and legal environment. The system helps solve several common issues, like traditional red team accesses are slow, noisy, and hard to repeat, and this is difficult to find the real sensitive file hiding among cycles or honey tokens. So our bot completes time-bounded mission with predictable and consistent behavior, which help create reliable testing results. So the main users are red team engineers, blue team analysts, SOC managers, and compliance officers and academic instructors. Here's a simple user story to show how the system works. A red team engineer gets approval for testing and set up the mission with a specific target and time window. Once it's authorized, the bot automatically scans for services, pick the quietest attack path, and hunts for extra sensitive documents hiding among realistic decals. After locating the correct file, it safely extracts the data, collects system log, and traces for replay, and then clean up the environment. Meanwhile, the blue teams receive data telemetry and timestamps, which help them review how well the detector worked, what's the signal they missed, and how fast they responded, all in a consistent, repeatable way. So let's move on to Weian.
Okay, thank you, Zixuan. Today, I'll briefly cover core functionality, what remains, the next steps, and our team insights. First, let's see the core functionality. It is in place. The tool accepts command line input, creates an output directory, waits until the target is reachable, and then runs multi-protocol probing across database, FTP, and SSH services. In parallel, a verification engine computes SHA-256 hashes and performs multi-format decoding, while also a lightweight image filter removes irrelevant pictures. Moreover, you can see that Jellyfin integration enables authentication, library enumeration, name extraction, and downloading of matching photos. Also, the scanner supports concurrent execution with live progress, which keeps long runs observable. With this baseline, I now invite Hao Mingchen to demonstrate our program.
Hi, I will introduce how our program works. Here we developed these two functions. For startup, it will take two parameters from command line and continuously attempts to connect the target. In the logs, we can it reads this block. These three functions is the core hash verification and file processing logic. And we write this for function for multi-protocol probing. And this one is to access the target host via SSH and search for passes and tries multiple sets of common credentials. This one is to access the target database via MSQL and search for tables that may contain log data. We can see the log here. It shows it's attempting MSQ database access, scanning common database ports, but no database ports are found open on the target. This one is to access the target via FTP and recursively scan directories to locate text files. In the logs here, it shows the FTP is attempted, but no log found. Then we do the Jellyfin authentic attack by using this function. So it basically attempts default accounts and obtain access token and user ID. So logs here shows that we have successfully logged in and using this credential. From here to here, we are using this function. So it's to access the target via Jellyfin API, and the logs indicates that we are conducting the info gathering through Jellyfin, and the program extracts the system information. Then we use these functions to retrieve all file lists through the Jellyfin Media Library API and filters files. So this block shows that script has has successfully traversed all files in the Jellyfin Media Library. Here is the final statistic. We processed all files, and no log file found. That's all. Thank you very much.
Okay, thank you, Haoming. Turning to what needs to be done next, we'll finalize the code and end-of-run report, remove duplicate SSH passes, and replace ad hoc prints with structured logging. At the same time, we'll clarify optional dependency checks, strengthen exception handling, add configuration support, persist scan state for resumable runs, and complete unit and integration tests. As you can see in parallel, we will enforce authorization and audit safeguards. In longer term, we plan to modularize protocol scanners, extend detection with fuzzy method, package for easy deployment, and add a lightweight status dashboard. Finally, this project has given us hands-on experiment in system integration, adversarial workflow simulation, protocol interaction, and secure automation. It has been a lot to learn. It also sharpened our skills in parallel enumeration, credential handling, threat modeling, and deployment. It's showing how cybersecurity theory turns into accountable, maintainable practice. That's all. Thank you for listening.